Let's talk about a piece of tech that's quietly working behind the scenes to protect your most important digital stuff. It's called RAID, and honestly, understanding it could be the one thing that stands between a tiny hiccup and a full-blown digital disaster.
I want you to just imagine this for a second. All your family photos, those critical work projects, the very operating system that lets your computer turn on, what if all of it just vanished in an instant? All because one little piece of hardware decided to give up. It's a horrible thought, right? But it shines a huge spotlight on a major weakness in how most of us store our data.
And that right there is the core of the problem. When every single thing you care about lives on one physical disk, you are just one mechanical failure away from losing everything. If that drive goes down, your system crashes, and your files, they could be gone for good. So what do? How do we fight back against this?
Well, we fight back with this really clever technology called RAID. It stands for Redundant Array of Independent Disks. And what it really boils down to is this. You get a whole team of hard drives to work together, but your computer just sees them as one big single drive. And under the hood, this team is working to do one of two things. Either make things way faster, or create an incredibly powerful safety net for all your data.
Okay, so to really get your head around RAID, we have to start with a fundamental choice. It's a trade-off. Are you building your data fortress for pure, unadulterated speed, or for absolute, bulletproof safety? Answering that question introduces us to the two most basic forms of RAID.
So on one side, you've got RAID 0. Think of it as the sprinter. It takes a file, breaks it into little pieces, that's a process we call striping, and writes those pieces to multiple drives all at the same time. This makes everything lightning fast. But, and this is a huge but, there is zero safety net. If even one of those drives fails, you can't put the puzzle back together, and all your data is just gone. Then on the other side, you have RAID 1, the bodyguard. This is all about safety. It creates an exact real-time clone or a mirror of your data on a second drive. One drive dies? No problem. The other one just takes over like nothing ever happened. The trade-off here is storage space. You pay for 2 terabytes of drives, but you only get to use 1 terabyte.
Okay, so we've got risky, blistering speed on one hand and super safe but kinda inefficient storage on the other. But what if there was a smarter way, a more balanced approach to protect our data without giving up half our storage space? I mean, for a business or really anyone with a ton of data, this is a massive deal. Paying for storage that you can't even use, like in RAID 1, is often just way too expensive. There's got to be a better way, right? And you know what? There is. The solution is this really cool mathematical idea called parity. Now, that might sound super complicated, but it's actually a pretty simple concept that gives us both data protection and way better storage efficiency.
Here's how parity works. Think of it like a simple math puzzle. Let's say your computer has data A and data B. It does a quick calculation and creates a special parity block, which we'll call C. Think of it like this. A plus B equals C. Simple enough. Now, data A gets stored on one disk, data B goes on another disk, and the parity block C goes on a third disk. So what happens if the disk holding data B suddenly fails? Well, it's no problem. The computer just looks at A and C and solves for the missing piece. It can literally rebuild the lost data from scratch. And that is the magic of what we call RAID 5.
Now, to pull off this little math trick, you need at least 3 drives. That's the minimum. So as you write data, it gets striped across the drives, along with all that parity info it needs to rebuild in case of a failure. It's a really clever way to distribute both the workload and the safety net across the entire team of drives.
So, this brings us to the pros and cons of RAID 5. It really is a fantastic middle ground. You get a nice balance of good read performance, you can survive any single disk failure, and it's way more space efficient than mirroring. But what's the catch? Well, the main drawback is that writing data is a little slower, because the computer has to do that parity math for every single piece of data it saves. All right, we've seen speed, we've seen safety, and we've seen a pretty clever balance between the two. But what happens when you decide you don't want to compromise? What if you want to combine them? Well, that brings us to what a lot of people consider the absolute best of both worlds solution.
What if you didn't have to choose? What if you could have that top-tier sprinter-level speed, but with the total peace of mind you get from having a dedicated bodyguard for all of your data?
Well, it turns out you can. It's called RAID 10. Sometimes you'll see it written as RAID 1 plus 0, and honestly, the name tells you exactly what's going on. It's a stripe, that's the RAID 0 part, of mirrors, and that's the RAID 1 part. It literally smashes together the two fundamental concepts we started with.
So, to build a RAID 10 setup, you need at least 4 disks. Here's how it works. You start by making two mirrored pairs, just like in RAID 1. So you have two sets of perfectly safe cloned data. Then, you use RAID 0 to stripe your data across those two safe pairs. The result? You get insane performance and incredible fault tolerance. You can actually lose one disk from each of the mirrored pairs and still not lose a single byte of data. The catch, as you probably guessed, is the cost. Just like with RAID 1, you lose exactly 50% of your total storage capacity, which makes this a premium choice for things like high-performance databases and other mission-critical stuff.
Okay, phew, we have covered a lot of ground here, from the risky sprinter all the way to the ultimate stripe of mirrors. So now, let's get to the most important question of all. How do you actually use this information? Which one of these rate levels is the right one for you?
Think of this slide as your personal cheat sheet. If you need absolute maximum speed for data you don't really care about losing, like a temporary cache for video editing, RAID 0 is your sprinter. For your most precious, can't-lose-it data, like your operating system or your family photo library, the pure safety of a RAID 1 mirror is perfect. For a fantastic all-around solution, maybe for a home server or a small business, RAID 5 gives you that great balance of protection and capacity. And finally, for those mission-critical apps that need the best possible performance and protection, think a busy database, RAID 10 is the king, as long as you can stomach the cost.
At the end of the day, RAID isn't just some technical acronym. It's a strategy. It's about looking at your data, deciding what it's worth to you, and figuring out how much you're willing to invest to protect it from that one single inevitable hard drive failure. So, the choice is yours.